All right, so what we're doing today is taking notes. We're talking about the different types of plate boundaries. We're going to talk about what each plate boundary does, where you might find it, what features you find there, some examples of the different types of plate boundaries, and we're doing another one of those spiderweb things. Mine goes landscape because that's the way my board goes. You can do yours that way, or you can do it portrait if you want. That is up to you. I'm going to use some different colors up here, just because I have them available. If you want to play along with different colors, you can do that as well. So, what would be a good title for our concept map?
Plate boundaries.
Plate boundaries. And we usually try to do just a really short definition with it. So we'll put plate boundaries kind of top center. And hopefully we know at this point that those are the edges of the crustal plates, or the plates of the crust. Plate boundaries occur at the edges of the tectonic plates. Hope we need a piece of paper. There are three major types of plate boundaries, and we classify them based on the direction that they move. We're going to start with diverging boundaries. Which directions do diverging boundaries move? Away from each other. So if we were going to draw just a quick picture of what a diverging boundary would look like, we would have to have two plates that move away from each other. And what comes up in the middle to fill the space? It's a ridge. We do make a mid-ocean ridge here usually. What substance comes up in the middle and makes new rocks? Magma. Diverging boundaries most often happen in the ocean. So most often this is going to be two ocean plates, one on either side. Although there are a couple of places where this occurs on land. So, what features do we get here? You already said that we get a ridge, like the mid-ocean ridge, that forms as magma hardens into new rock. Because the magma is coming up in the middle, that's where the youngest rocks would be located. So as you move out from the ridge, the rocks would get older. So older as you go out. The youngest rocks are in the middle. The oldest rocks would be by the beach. Let's put a few examples of where these types of boundaries occur. The Mid-Atlantic Ridge is an example of a diverging boundary. That means that the United States and Britain are getting further apart from each other little by little every year. One place where the Mid-Atlantic Ridge comes out of the ocean or is on land is a tiny little country, an island country in the Atlantic. Can you think of what it is? It is Iceland. So we'll put that in parentheses. That's the one place where the Mid-Atlantic Ridge is on land. And then we'll put one other example because most diverging boundaries are in the ocean, but not all of them are. We're going to list another one that's not, and that is called the East African Rift. If you know geography of that continent, it's over by Ethiopia, where that part of Africa kind of juts out on the right-hand side. That's where the East African Rift is.
Wait, so in the Indian Ocean or the Atlantic?
That one is not in the ocean. That one's actually part of the continent is kind of like it's separating, but there's new rock coming up, so it's not really going to make...
Yeah, you said left.
It's not a trench.
Indian Ocean or Jersey?
Oh, I see what you mean. It would be on the side of the Arabian Peninsula. So to me, that's the right-hand side if I'm looking at a map. Okay. Next kind. We're going to go ahead and do the other shorter type of boundary, or the one that has the least amount of details with it, over here on the side. And that is the transform boundary. What kind of motion do we have in a transform boundary?
The Pacific.
LA.
That's an example. What kind of motion?
Oh,
Yeah.
motion. I thought you said
Sliding motion.
A sliding motion, side to side. So if we were going to draw a picture of this, we might just do it with a couple of arrows. One plate goes one direction, the other plate next to it goes the opposite direction. It's more of a sliding motion, side to side. And that's what we'll put for our description of this too. Like our definition, plates slide past each other. In terms of what features do we get here, there's not so much land features or geographic features as there are events. Earthquakes. These boundaries are commonly associated with earthquakes. So we'll put that earthquakes are common. But there's one thing that's different about these earthquakes from some of the other ones that we're going to talk about with our third kind of boundary. The earthquakes that occur at transform boundaries are typically very shallow. That means, at least comparatively, comparing to other kinds of earthquakes, they occur pretty close to the surface. They're not very deep underground.
So what would that be on the scale?
Well, you can still get a pretty big range on the Richter scale in terms of magnitude, but the depth that they occur at is much less. And of course, our most famous example, what's that fault line called?
San Andreas.
San Andreas Fault in California.
San Andreas.
Okay, now the whole rest of our space is left for what kind of boundary? Converging. And we're going to need the whole rest of the space, and we're going to be challenged to get it all in here, because converging boundaries collide, but they can actually be broken down into two subtypes. So we'll start with converging. We know they collide, so if we were going to draw a little picture, we might just have two arrows coming at each other. But there are two subtypes of converging boundaries, and that depends on what kinds of plates are converging. So if we say we have a converging with collision boundary, what kind of plates are involved? Newt? Yeah, both continental plates. And if you have two continental plates, what does that make in the middle?
Mountain.
Mountains. So if we were going to draw a picture for this one, first plate, there's some mountains, and the second plate. And I'm just going to label that with a C to stand for continent. Continent, continent.
Another one. Bless up. Stay away from that.
What features do we have here? Of course, we have the mountains. An example of a place where that happens, there's actually two pretty famous mountain chains that occurred because of this kind of boundary. The Alps in Europe and the Himalayas in Asia. One other thing that you tend to get with these types of boundaries, less frequently than with transform boundaries, but you can still get earthquakes. And that should make sense, because if you think about two continents pushing against each other and making mountains, it would make sense that that process is going to cause some shaking of the earth along with it. Anytime in the news you hear about earthquakes in China, Pakistan, Afghanistan, that area of the world, it's because of the Himalayas and the boundary that's created there. There was a pretty bad one in Pakistan in 2005, and they've even had some more since that one. There was another one in 2011 in that same country that was pretty severe. So less frequently than with a transform boundary, but you do still get earthquakes with collision boundaries. I'm going to switch colors one more time just because it's getting a little bit crowded up here. We can also have converging boundaries with, what's the other kind?
Subduction.
Subduction. And if I was going to draw a picture with arrows for that, I might draw one that's kind of headed downwards and another one that's more just headed over. Two plates collide and one of them gets pushed down into the mantle. This can occur with two different combinations of plates. You can have this kind of boundary with ocean plates, with two ocean plates. One of them would be pushed underneath or one would subduct. The features you would get there would be deep sea trenches. Do you know the name of probably the most famous deep sea trench? Marianas Trench. It's in the Pacific. And that is the deepest place in the ocean that we know of. kinds of plates, or this kind of plate interaction, can also cause earthquakes. The difference between these and the transform boundary ones is that these are very deep earthquakes, meaning that they occur very far under the surface of the earth. Because they occur in the ocean with two ocean plates and very deep underneath the earth, they can cause tsunamis, giant waves. So, for example, the 2004 tsunami in Asia. Oops. What is that? Gotta spell it back. Spell it right. There we go. Tsunami. That's better. Yes, that was the worst one. The 2004 tsunami in Asia was caused by that kind of boundary. All right, we've got one more combination to squish in here. You can also have a convergent with subduction boundary, where you have an ocean plate and a continental plate, and in that case, it is the ocean plate that subducts. The ocean plate subducts because it's more dense, it's made of basalt, it's heavier. The continental plate is made of granite, it's less dense, it stays at the surface. The ocean plate subducts. Couple of things that you get. Mountains on the continent side. And I'm abbreviating a lot because I'm almost out of space. You get mountains on the continent side. You also sometimes get deep earthquakes and volcanoes. Not Hawaii. The example of where you would get those things, mountains on the continent side with earthquakes and volcanoes. So a few different places in the world where that happens, but our example is going to be the state of Washington and Oregon and just a little bit down into California. What famous volcano is in that area there?
St. Helens.
Mount St. Helens, along with Mount Rainier and Mount Hood. The Cascades is what those mountains are called. Those are formed by the plate boundary of the Juan de Fuca plate pushing against the North American plate and subducting there. Questions?